Good morning, everybody. This is Mr. Brackett. I have another video, and this is probably a secondary video to the last video that I created. A video that is meant to help you address internet issues, connectivity problems that you might be having. The last time I created a video, I showed you how to open a command prompt window and run some basic commands like ping, which helps you determine your communication with an outside server, and I also showed you how to do IP config to get an idea of how you're configured for accessing the internet. And on this computer you see I have an Ethernet access. So IP config and ping were the topics of my last video. This video is going to be about Traceroute. Traceroute, which is Tracert. You can see it there, but maybe I should make it even bigger. Traceroute. You can use Traceroute to get a sense of connectivity issues in a more detailed way than a ping. So tracert is more detailed than pinging. So let me show you how it works. It works very similarly to how ping works. You'll see up here that I pinged 8.8.8.8, which is a Google server. And in my last video, I showed you how to ping other sites. Tracert pretty much works the same way. I can run tracert and then put in an address and hit enter. And you'll see this is tracing a route to Google's public DNS servers, which are registered at 8.8.8.8. And so Google's public DNS, I'm not going to explain it to you because you probably don't really care. But you'll see while I'm talking, the tracert is creating output. And that output continues to build even as I'm talking, and we're waiting for it. So I want to explain this output to you. You'll see that it says it's tracing a route over a maximum of 30 hops. And what that means is that after 30 hops, and a hop is a trip from one switch or one location to another, after 30 hops it's going to stop. Now, you can change that if you like. You can change the number of hops, and let me show you how that happens. That's not it. Oh, no, that's going to fail. You do it like, that's not it. Alright, well, I'll have to get you some information about, there we go. So I run tracert with a slash, a forward slash, and a question mark, and we get possible usage. You see with a -d, there's no resolution of addresses to host names. So up here, where 8.8.8.8 was turned into this host name, you can hit /d for that, or -d for that not to happen. And there's a bunch of other usage here. If you hit -h and then put in a number, you could end up with a different number of hops. So if I hit something like tracert 8.8.8.8 with a -h and 50, then well, I did something wrong, didn't I? Oh, so the target name goes after all of that. So tracert -h 50 8.8.8.8. Okay, now you see that we're tracing the route to Google's public DNS with a maximum of 50 hops, which means we're going to get more output. Up here you see that it only took 20 hops for us to get to Google's DNS. But if it takes more, if you run a tracert and it fails after a certain number, you might want to increase the number of hops so that you can make it to your target. So here it's running the same basic trace route that it did earlier. And so here's what that output is. You see the first hop 2 milliseconds, 2 milliseconds, 2 milliseconds, and that's to 10.10.254.1. That is a local switch inside our network. And then you'll see that number 2 and number 3 here both have 75.75. something, and that is our external IP address. And so at this point, in the first 3 hops, we have made it outside of our school's network. If we were having network connectivity problems, like we have a problem with our connection here on campus, one of these first 3 connections, first 3 hops, would have failed. But you see that they don't fail, and then we move on to hop 4 and 5 and so on. You see acd.net here and here, and also here and here. acd.net is our service provider, and so we're continuing to use switches that belong to our service provider until we get to about here, metroix.net. We're connecting here to 69.89.98.2, and here it's pretty much the same thing. So these two are related. You see the IP addresses are very similar. So these are probably switches owned by the same organization, and we're bouncing off of those. And then you see here Zio.com. We have a whole string of those. Zio.com is probably just another service provider. And then eventually these 2 hops, hop 18 and hop 19, are taking us down to Google's IP and local switches, and then this is their DNS server. And so we trace the route very literally from our location all the way down to the location that we put as our target. And you can see the number of milliseconds that it takes each of those to complete. So we complete a hop, the first hop, in 2 milliseconds. Our second hop takes even less time than that. Some of them tend to take more time, especially when you get out into the world where maybe their connection isn't as fast as what we have here on campus. Things might slow down a little bit, but you see that still we're in a very small amount of time. 42 milliseconds is a very small amount of time. And then the amount of time that it takes for us to reach out to Google DNS is a compilation of all of these hops. It takes 2 milliseconds and 1 millisecond and then 2 milliseconds and then 7. And if you were to add all these up, it would give you a basic idea of how long it takes for us to reach out to that Google DNS server. Then at the bottom it tells us trace complete, and that's the end of that. If any of these numbers were amazingly huge, like 600 milliseconds, there might be a problem at that location with your connectivity. So say I was trying to get onto Pinterest, and it wasn't working, and I was thinking about calling Mr. Brackett or emailing him. I could instead run my own trace route to find out what's going on. And so I see that the Pinterest server in the public world is 104.156.85.84. And so we're going to leave our place, 10.10.254.1, and that might be different depending on what building you're in. We then head out into the real world. These are our public IPs. Then we head through all of acd.net's connectivity. Then we're into MetroIX, probably some service provider, and then MetroIX is going to take us down. We go through some switches that aren't identified, and then we end up here at chicago.level3.net. Chances are this is just another service provider. Then we get a request timeout here, which is interesting. If you get a lot of these, it can sometimes indicate that there is a connection problem at that point in the trip. But then you see that the next hop 14, is 104, 156, 85, 84, which is the Pinterest server. We eventually make it there, and it says trace complete. And so if you were having a problem getting to Pinterest, running a traceroute command would give you an idea maybe where that problem is happening. I use this command myself to try to analyze where connectivity issues are occurring. So sometimes if people say that they're having a problem getting to a place, I'll run a trace route to see where the connectivity problem is happening. And so that might be something you want to try to do the next time you're having a connectivity problem. I hope this video was helpful. Thanks a bunch.